Welcome to week 2 of Module 4, Understand the Treatment System. This week we are going to look at the treatment system that changes the characteristics and composition of waste streams, converting them into valuable other products. Last week you learned that production involves the transformation process of an input, such as organic solid waste, into an output, like for instance compost. You also learned that the transformation process involves transportation, treatment, and storage, and that you need to consider all these different elements when planning your process. At the end of last week, you have prepared your process flow diagram indicating the individual process steps in chronological order. Now, it is time to look at the treatment system for converting the waste input into other products with an added value. Technologies are usually arranged in a treatment system with 3 distinctive steps: pretreatment, principal treatment, and value addition. The aim of pretreatment is to prepare the waste for the principal treatment. This could be done by removing other waste fractions. For instance, the screening step that removes trash from wastewater, or the segregation and sorting carried out to separate the inorganic fraction from the organic solid waste. Adjusting the size of particles, like the shredding of agro waste before it reaches a biogas plant. And mixing different types of raw material, for instance, the organic waste with fecal sludge in co-composting. After the pretreatment, the principal treatment transforms the waste into a product by changing its composition, changing its states, for instance, from solid to gas through biogas production, changing the volume, and reducing the pathogen content. Finally, the aim of the value addition or polishing is to increase the value of the product. Examples of value additions are removing impurities such as water vapor, carbon dioxide, and hydrogen sulfide in the biogas. Adding supplements, which is the case of the production of fortified compost through the addition of nitrogen, phosphorus, and/or potassium. Changing the form of the product like pelletizing and packaging. Usually, all these steps create secondary products that also need to be properly handled, either by further treatment or appropriate disposal to avoid negative impacts on the environment. For instance, any segregation of solid waste produces an inorganic refuse that needs to be transferred to a recycling plant or any other solid waste management facility operating in your local area. For each of the treatment steps, the treatment can be classified as biological treatment, which is the controlled conversion or degradation of waste by living organisms, for instance, to produce compost. Physical treatment, which is the removal of particles by methods such as screening, settling, and filtering, or the change of phase or size of a component. Chemical treatment, which is the use of chemicals that cause reactions such as pH neutralization, oxidation, or reduction and precipitation. Because of the key role of biological treatment in other treatment processes, it is key to understand the differences between biological treatment under aerobic and anaerobic conditions, so with and without the supply of gaseous oxygen. Keep in mind that under both aerobic and anaerobic conditions, the growing and reproducing microorganisms or bacteria which degrade the organic matter require a source of oxygen to survive, exactly like we do. Under aerobic conditions, the microorganisms access free gaseous oxygen directly from the surrounding atmosphere. The end products are primarily carbon dioxide, water, new cells, and energy. This is the case with composting, when the input material is organic waste and the resulting product is compost. Under anaerobic conditions, there is an absence of gaseous oxygen. Therefore, anaerobic microorganisms obtain oxygen from other sources like the organic matter itself. The intermediate products are primarily alcohols, aldehydes, and organic acids, plus carbon dioxide. In the presence of methanogens, the intermediates are converted to methane, carbon dioxide, with trace levels of hydrogen sulfide. This is what is called biogas, a key source of energy. It is important to understand this difference, as technologies used for biological treatments usually offer aerobic or anaerobic conditions for bacteria to decompose the organic matter. Keep in mind as well that physical and chemical processes are combined in specific technologies for the conversion of waste into valuable other products. These are called physico-chemical treatments, which refer to conversion processes that are induced by chemical reactions or apply physical mechanical forces. This is what is used to produce non-carbonized pellets. And thermochemical treatments, in which heat is applied to induce chemical reactions as a means of extracting and creating energy carriers as products. These include processes such as combustion, pyrolysis, and gasification. This is what is used to produce carbonized pellets. So, before I introduce the specific technologies, let's recap what you have just learned. Now you know that in order to convert a waste stream into an other product, you need a treatment system composed of 3 steps: pretreatment, principal treatment, and value addition. You also know that for each of these steps, you can have biological, physical, or chemical treatments. Biological treatments can be aerobic or anaerobic. Anaerobic degradation produces biogas. Physical and chemical treatments can be combined in a technology offering physicochemical and thermochemical treatments, the latter being relevant for the production of energy. Now, let's take a look again at the overview of the waste to resources options. We can categorize the different technologies available according to the potential for the recovery and reuse of energy, nutrients and organic matter, and wastewater. This way, we obtain clusters of technologies intended to recover nutrients and organic matter, such as composting, co-composting, and vermicomposting, technologies to recover energy from organic waste, such as anaerobic digestion, densification, pyrolysis, and gasification, and technologies to recover water from wastewater for agriculture, forestry, and aquaculture. Next week, we will take a closer look at these different technologies. So, in week 3A, you will learn about technologies for nutrient and organic matter recovery, such as composting and co-composting. In week 3B, you will get to know about technologies for energy recovery from organic waste, like incineration, biogas production, and charcoal pellets. And in week 3C, you will learn about wastewater treatment technologies for irrigation and aquaculture. You should definitely watch the video in which I explain technologies associated to your business model, but you're welcome to watch all of them. See you next week.